Hi, Eric here. Today I'm going to show you how to convert floating point values into their respective fractional representations. And hopefully I'll be able to show you this in Java and also in C++ here. So I have Visual Studio and Eclipse running. Let's begin with the C++. Alright, here's our class here. It's pretty simple. I have four variables here: the denominator, the numerator, the fractional part, the integer part. As for our methods, we have our constructor here, and we also have our function rationalize, which just returns the fractions. Here's a small driver to simulate and sort of test if everything is working out. So we have a 0.25, which is a quarter. We have a 0.75, which is 3/4, and 0.375, which is some value that we'll find out soon. And alright, so in our implementation file here, the first thing I do is we initialize the numerator and the denominator. It's important to note that to avoid the exception of divide by zero, or the error divide by zero error, it's important to initialize the denominator to a non-zero number. So here I've chosen 1. And also another important thing, I'll be using mod f here, which is a modulus f. It's available in the CMath library, and what this returns is a fractional part of the floating point value that you're given. And also it does return the integer part, or the whole part of your floating part value. Alright, so here's where our function begins, and I just print out the value as a first step here, just to show the user what's going on. And then we jump into this loop here, where we loop while the fractional part is not 0. Alright, so this is what's happening here. We have, let's take an example, 0.375. The fractional part is 375 here. So on the first iteration, the fractional part is 375. On the second iteration, since we multiply the value times 10, the fractional part is 75. On the third iteration, since we multiply the value again by 10, the fractional part is 5. On the fourth iteration, we multiply the value by 10 again, and the fractional part becomes 0. At this point, we jump out of our loop here. And if you do realize here, for the denominator, what's happening is we're multiplying it by 10 with each iteration. So eventually what we end up with is 375 over 1,000, and that's when you break out here. And then this step here, I'd advise you choose a Euclidean algorithm. It's available on Wikipedia. They have a really good example and a formula for that, so you might want to use that instead. It's efficient and obviously easier to code, or a fewer lines. But anyway, this is what I do here. I just check using the modulus operator. We check if we can divide both the numerator and the denominator by specific values. And for me, I chose 9 through 2, or 2 through 9. So for example, if I can divide both the numerator and the denominator by 9, that means I can simplify that value by a factor of 9. That's how we are going to simplify our fractions. We do that for until when we can't simplify the fraction any further, and then that's when we just print out the answer here and break out of this loop here. And I have a small sleep function. This is only available for Windows, so if you're running this on a different platform, this will not work. And you reinitialize your denominator back to 1 for the next set of numbers. So let me quickly run this and show you guys how this runs. Alright, so we start with 0.25 there. The first thing it does is change that into 25 over 100, then divide both by 5. You have 5 over 20, divide them again by 5, we get 1 over 4. Same thing for the rest here, and it continues and continues and continues until we're done. So basically that's what's going on there. Let's quickly switch over to Java. Let's maximize this. Alright, so that's our main function here. This is our main point of execution. and we just call the function here. And let's look at our class, our Java class here. I have two text files here. This is what prints out the whole procedure. It shows what happens in the background, and then these are my input values. So I'll basically be reading my doubles from this file here. Okay, so we set out everything as we did in C++. We have a scanner to read in values, or in this case to read in from a file. We have a print writer to write to a file, and a numerator and denominators. It's important to use a try catch for your files here, so that to avoid any sorts of exceptions that might arise, and you're able to catch them and kind of troubleshoot from there. So we have a loop here, and it just loops as long as there's a value we're reading from. As long as we don't reach the end of the file, we keep on reading, and essentially do the same thing we're doing in C++ here. And the only difference is I'm using the modulus operator here, divide by 1. What this does is, if for example I had 0.375, which was assigned here as our new value, if you had like 0.375, if you divide that by 1, or if you use a modulus operator 1 on that, you'll just get back 0.375. We keep on doing that until this operation returns 0, which of course will be when our fractional part 0.375 has become 375. We break out of that loop and continue with the same process as we did in C++. For the full solution for both of this, log on to www.cs.uml.edu/tilde this is Eric, and keep tuned for more tutorials. And also, while you're there, you can look at my other projects and post comments for this video, and I'll respond to them when I can. Again, this program does work for negative values, so if you want to try that out, be my guest. Thank you.